Okay, great. Thank you for joining us today. So, good morning and good afternoon, everyone. Thank you for joining today's Horin Software online session. We're glad to see participants join from different regions and industries. Whether you're new to Horin or already familiar with our software, we hope today's session provides useful insights and a clear understanding with our software workflow. So my name is Beryl Chen from Horin Sales and Training Team. I will be your host today for this webinar. And our main focus today is the training with Horin, Geology-Constrained three-dimensional gravity and magnetic inversion workflow. We appreciate your time and we hope this session will give you practical and valuable insights into Horin's modeling workflow. So today we'll help you understand how Horin simplifies and accelerates the modeling process. And this is also the first part of this is the third part, sorry, of multi-week training sessions. So as you know, we already have several training sessions before. We already covered implicit geological modeling, multi-source data integration, 3D interpretation, and we also will have more upcoming sessions covering mobile platform like airborne and marine gravity magnetic data processing, electrical magnetic processing, and also integrated interpretation. So each session will build up on the other one to give you a whole picture of Horin's workflow. And we try to get you to know more about Horin, our company. So Beijing Horin Exploration Technology was founded in 2009, and we are the developer of Horin software. Our team consists exploration geologists, geophysicists, and senior software engineers, each with over 10 years of industry experience. So this background allows us to design Horin not just with software product, but also it is a tool that allows real exploration workflows. Horin is developed to support the full exploration process, from geophysical data processing and inversion to integrated geological interpretation and three-dimensional modeling. With more than 14 years of development, our software suite have become a widely adopted tool across mineral exploration, energy sectors, and geological consulting. We work closely with real field data and the real exploration cases to understand common technical challenges. One of the key ideas behind Horin is to keep geophysics and geology connected rather than treating them as separate steps, separate tools as other softwares in the market. Through today's training, we'll focus on how Horin handles real data, how different models work together, and how you can apply software efficiently in your own exploration projects. So now I will hand over to my colleague to introduce the Horin software structure and today's focus.
Introduce our software. Um, by our software, you can change your row survey data by our by processing with our Horin software to your finally results, and so you can produce the your report by the by any kind of by every derivative every derivative you can um, you can use in our by you can to make the derivatives by our Horin software, and we have database visualization, grid visualization, and map profile 3D, another lots of functions. Let me introduce about it. Our software combines of different models. One first is the basic models. We call it platform. that include grading and the map and section map and classic 3D geological modeling functions, and also coordinate tools, database tools, and and a grid tool, map tools, and not any other tools here, and on the basic of the platform, we have advanced models. Um, for example, there's a gravity and magnetic data processing model, and 2D and 1D filter, and inversion model, both gravity and magnetic inversion, and electronic model, and 3D Euler inversion, and EM data collecting tools. Lots of tools here, and we also have uh, marine and marine gravity and magnetic models here. And we in the geoscience model part, we have implicit geological modeling part and and the drill hole modeling models. Into today's tutorial, we are going to explore the 3D gravity and magnetic inversion by the geologic constraint by the 3D implicit models. Inversion is fun. If you have survey data, for example, you have gravity survey data and you have magnetic survey data, and by processing, you can get the magnetic anomaly. Uh, and by the anomaly, if you want to know what is something on beneath the earth, and and we can do inversion. So inversion is actually is to try to fit uh, try to fit different the distribution of different density or different magnetic suspectability uh, of each grid underground, and to calculate, and computer will calculate what is the if the gravity, for example, if this gravity is density. So if you have gravity, you have density, you have density model, and you can calculate the gravity anomaly of the surface. And so for inversion uh, is a repeat process to make the models fit the surface anomaly. So if the fitting is good, we can if we import the anomaly data, and you can get the model of subsurface magnetic susceptibility or density, and this will help you to find the objects or some features you want to look about in your project and your work. And in Horin software, we have we have a great feature is to convert the implicit geological model to the initial model of the inversion. This will help us to reduce the calculate amount of the inversion, and and also the you will, because inversion you have uh, you can have a very quite different models, different quite of density distribution or magnetic distribution that will make nearly the same anomaly on the ground. So, but some of the results were not reasonable for geology concepts. So, uh, by the implicit geological model, the geological concept will induced to the calculation to constrain the model to constrain the inversion results. And this is a case. This is a ore. This is a ore in China, and by the magnetic inversion, uh, our client can identify where might the ore can be. Uh, for in this example, and our client was previously to plan to. 那那怎么办？看见吗？嗯。Okay. Okay. I'm sorry. In these cases, in this case, our client um, will plan was first plan to drill hole on the west side and in the left hand side of this slide, and but for before the drilling, they use our software, our Horin software to do the magnetic inversion. So they identify that it might be no ores. The possibility of ores is very low in the west side, and but in the east side, maybe a little far from the our outcrop before, but there might be an ore that will in a shallow and near surface zone. So after inversion, they focus on the east, and they find a little outcrop, but it's not very large outcrop, and is far from previous mining sites. So it's previously it's not very there was not quite sure if there was a large ore in the subsurface. But after this inversion, they were more sure about the east side ore. So they drill the east side, and they got the ore. They find the ore in the east side. So our Horin software can help our clients to find the object they want. And and this is next step. We're going to do a live demo of 3D gravity and magnetic inversion. And this is we have 3 steps. First step is initial model to build the initial model. To and second step is do the inversion, and the third step is visualization of the results. Okay, and after these sections or during these sessions, if we have trials, if we have our trials, you can if you get our data and our tutorial data, you can just try it in your computer for the inversion. And so let's go into the software. And first, we are into going to the software interface, and now it's blank here because we didn't have any projects. So the first step, we can build a new project. You can browse. You can to build. Let me check where to build our project. Okay, here. Okay, and then the project, and this is optional. You can to insert your organization. And when wait a few seconds, the project will be built. Okay, and now the project is built, but there's no data. So first step, we import the data, and we click grid and open to open a grid here. Okay, for the initial data, we have three. We have three grid files. First is the gravity anomaly, and the second one is elevation, and the third one is a magnetic anomaly, and this is all in the same place. So first step, this is a high. This is actually a DEM. So you can click here, double click here, and to choose the plated to. For the DEM, sometimes we use this terrain, and we choose the linear to keep the plane green. And click OK. Maybe we can have some shadow effects. Okay, this is optional. You can choose different kind of. You can adjust the parameters of this shadow. After this, shadow was built, and this is a DEM here, and gravity also you can choose. There's a color map editor here. You can to edit the color mapping method you want, and all of the parameter you can set here. But no, we are not going to set this because we are going to just do inversion, and let's take a look of our inversion functions here. Here, 3D gravity and magnetic inversion. We click here, and we can see there's a different function. This is first is create initial model, and the second one is also to set the physical property initial model. But we are now you just use the initial model, and the third one is implicit model to initial model, and we are going to do this. And this is inversion, and this is forward modeling. Actually, inversion is just lots of forward modeling, and we have lots of irritations to make the fitting more accurate. And the last function is model property normalization. You can normalize the data to the appropriate range. So although we are going to show this implicit model, and but we can first introduce this kind of initial model. If you didn't have geological constraint or didn't have geological implicit geological models before, you just want to build a uniform initial model here, you can use this function. And for this function, first you can insert the grid data you want. For example, here, if you gravity data, you just click it, and to choose DEM here. And as you can see, but there's with the DEM data, the grid will be a little offset by the topography to make the grid just fit the surface. And all of these parameter you can set. For example, here you can, if you want to only inversion for the shallow parts, you can just to modify here and to click apply, and this the model content will be will be different by your settings, and with three direction we have different parameters. Okay, I'll just put it to 20 kilometers here, and this is mesh width, and this is number of meshes. And for example, if you choose 10 for in the X and click apply, and you can see in the X-axis, there will only be 10 meshes. And another function is if you want to focus only the middle, and you can use this increase and decreasing. Maybe we'll just use 20 here, and and to select the rate, for example, 1.5 here, and you can see the middle part of the grid in the middle will be denser. So if it's 1.1 or 1.2, that will be the effect will be different. You can just choose which you want. But but we just use one here, and different. Oh, I can try the z value. If you can x y z three direction. You can is this in if you is average is the same, but for the z direction, you can use the increasing. There's an increasing, and 1.2 and 20 here, and you can see the z volume that was shallower. In the shallow part, there was denser, and in the deep part will be sparse. But usually we use this kind of because the because the resolution in the deep part of inversion is usually lower. And for the average, the interval will be the same. And in the part here, in the left-hand side, you can choose you want to build a density model or a magnetic susceptibility model, and this is the initial value to build a to build a uniform model. Here, if you want to do an inversion of anomaly, for example, the residual gravity anomaly, so you can set the density as to 0, because because the residual gravity anomaly is usually near more than 0, and sometimes lower than 0, but the average will be close to the 0. So you can set this as the initial model. And click Save Model, you can save your initial model. But in today's tutorial, we are focused on implicit model. So we just click Close, and we can import our geological model. Of DM is not imported, but it's okay. Here is a implicit model that was done before, And in the previous tutorial, I have introduced about these models. And if you are interested in here, you can contact our you can contact us to get the tutorial data of different models. And here is a 3D geological model. Uh, the different color represent the different layers or different stratigraphy unit here. And we can first, we just to export this model. Sorry. Now we can save. To save the model, you can choose the you can choose the storage model files and the stratigraphy files of each. And load to a new model and the name. Okay. And now we are going to inversion. So in this case, we just use implicit model to initial model here. And now you can select the virtual model. Okay. Okay. Well, first I have to where is the model? Wait a minute. Uh, you can see this is the data structure here, and we have our project file and our Horin 3D, and this is 3D versal, and we have lithology model here and a stratigraphy interface file here. And we can import the versal model and the stratigraphy model here. And we can to manually to input the magnetic susceptibility and the density here. And for example, we just give some to some volume here. And because we are using gravity anomaly, so the density will also be the anomaly. So it might be minus or plus. And in different layers, the density and the magnetic susceptibility will be different. So maybe 0.2. Just insert some volume. Okay. And after this, and you can choose where the model should so save to proceed. And in the default, we just so saved in the same folder. Click OK. Okay, and the model was saved. And next step, we are going to do inversion. First, we do the gravity inversion first, and so I click the gravity inversion and set to select the gravity observation data. Here is Grav, and this is uh, different options. First is observation elevation. If your data was collected at the surface, you can choose this. And if you have terrain, you can. I'm sorry. Here, if your data was collected in the surface, you can click here and to select the observation terrain here. And if your data was collected in a certain elevation, or you just don't know, it's nearly zero, you can use this. Or if the elevation is about 200, you can just use 200. But here we use this, and we have a DEM because our data was collected in the surface. And this is an initial gravity volume. We proceed and to find the density model I just built before. Click OK, and you can select the number of irritations. We just use 10 and 20. And there's a depth parameters. You can choose that you are distance wide or depth wide. And there's a gravity depth weight. This weighting, why we need this weighting? Because the shallower part affects the gravity anomaly a lot, because the gravity force will be stronger if the two objects were very near. So if we didn't introduce this depth right, the model will like to put all of the anomaly in the shallow part to fit the result. But actually, we will not only have only shallow part, we also have a deep part. So there's we induce here is 2, because gravity is if the distance is 2 times, 2 times, and the gravity force will be 2 plus 2 and equal to 4. So in this case, we just use this power of this 2 to reduce this volume to make all of the dips, all of the different dips, they have the same. Actually, they have the same weight. So if you want to focus on the shallow part, you can choose to adjust this to maybe to 1.5, or even you can just use 1, and you can make a different inversion to compare the results. And this is sometimes you have the depth offset if you select the depth weight. This is because if your data with a little bias, maybe in some grid, the data will be very the center of the grid will be very near to the observation point, and the distance will be nearly 0. If the grid if the distance is nearly 0, and the gravity force will be very large, in theory, it can be large to infinite. So we do a little offset. Sometimes maybe a half of the grid size. If your grid size is 20 meters, you can just use 10, or if you or 0.1 to avoid the distance to very near to 0. and we can use this distance weight here and click OK. And we are going to do the gravity inversion. So let me check all of the parameters is correct. Okay, okay, it's 0. Just set this to 1. Okay, let's start inversion. And in this dialog, you can see first is the total number of grid observation points is about 12,000, and cell in the gravity model cell is 100,000. So this may take maybe a minute or 2 minutes to finish this. Click OK. And in this part, you can see the the inversion status. Just wait a few seconds. And this, if you have a lot, if your RAM size was large, you can use a thinner grid. And but if you have some your RAM, you didn't have a lot of RAM, you can just, oh, you want a quick answer, you can't to adjust the grid size. In this case, the grid size was defined by the implicit model. I just use it, and the after this after this you can the fitting results will pop up, and you can see the left side is the raw data, and in the right side is a forward modeling results of the inversion data, and in the right side the picture is a residual. You can see the residual is low. Click close, and now you can see this. This is a gravity inversion result, and you can also change the different mapping method. Maybe just if you want here, you want this will be different, but this is some high value here. And so you can use the histogram equalization to reduce this, and we just go back to a color to here. You can see, and the implicit geological model results here is truly constrained the results. So because I just insert the random modeling of density anomaly, so the result will be some kind of strange. But if you insert the right density anomaly of each layer, and the model result will be more accurate or more make sense. So after this, we are going to do the magnetic inversion, and we just build the initial gravity model and initial magnetic model by the implicit model. So we just click it again, but now we use the magnetic inversion. Okay, and the magnetic data and the observation terrain is H, and this is the magnetic fitting results. And here you can use the magnetic model, initial model here, and this is an inversion model, and this is a magnetic field parameters, and this is you have to insert the geomagnetic field of your site, I can show you by several maps. Uh, you can see there's a map of global magnetic field declination here, declination, and here is inclination, and here is total intensity. So for the tutorial, we just use 60 here and 0 here and 50,000 here, and this is the x-axis azimuth. In because we are x-axis azimuth is towing east, so it's 90 degrees. Okay, click OK. And this is the same. And parameters we use 3, and this offset we use 1, and just start inversion here is the same as gravity. It is the same as the gravity gravity inversion, because magnetic and gravity inversion is the theory is quite similar. Just wait a few seconds until the inversion is finished. Okay, and inversion finished. And also you can see the residuals here. And this is a magnetic field. And we have various functions you can to explore the 3D vessels. First, you can add the 3D surface. For example, it is a magnetic inversion, so we can use the magnetic grading here. And you can see on the top is a magnetic anomaly, and in the lower part is the magnetic susceptibility anomaly of a subsurface area, and you can offset here to and if you can offset you can offset the surface or to this. Okay, and the next is can do the 3D slice here. And by these 3D slice functions, you can choose if you want to X direction, and you can choose the spacing, different spacing, and different azimuths here, 0, and a different direction here to make a 3D slice. Maybe we'll use this to make a full slice, and you can see there's a 4 sections here, and to show that the different the different magnetic susceptibility of each layer. And then we can use that threshold. For in the threshold function, you can just to display some data in a certain range. Here, we just use detail. Maybe this, the higher value here. Click OK. And you can see the high value will be shown here. And we just to close it. And the next one is a chair clipping. In the chair clipping function, you can manually to to define where you want to clip and to show the structures of any part you want to show the structures, or you can use this to show the different part, and the Y and the Z, show different part, and you can manually to to choose which you want to show. Click OK, and you can see there here is a this is the surface. You can see the surface in maybe about 10 kilometers, and anomalies here, like here, distributions like here, and you can also to change different, maybe like this, different, and you can have two sides, maybe like this, maybe this. Okay. And then we can just load the geological contact surface. Oh, we didn't save it, but it's okay. We didn't save it. Okay. We can put this. If you save this this surface, and you can display it on here. I just skip it, and we'll go back. And this is a gravity inversion model here. And if you think here is a high volume in the top, you can choose the different parameters, or check the maybe to choose the different offset amount to avoid this kind of situation. And we have normalization functions. For example, here's the gravity. You can right click and choose the properties. You can see there's a property, the mean property and the max property. And if you want to clip some bias, maybe if there's a very large amount of a very small amount, you can do normalize. In this part, we just use the minus 0.3 to 0.6, or maybe 0.7. Select the inversion model, and to normalize maybe to minus 0.3 to 0.7. And we choose the 3% of data to remove. Here's the model. Yeah, I didn't find the model. Okay. And the model will be a little different to remove the high value of low values, the extremely low value or high values. Okay. And now this is the end of tutorial of inversion, 3D inversion. If
Okay, so we have collected all the questions and the answers which you can see here. And we could also share after this training session. You can just email me. So since we have answered all the questions, I'm just gonna show and quickly show and go to the last part. We hope this session helped you to gain a clear understanding of Horin's workflow and the tools available in our software. If you'd like to try the software yourself, you may request a free 30-day fully functional trial by emailing me. So here shows my name and my email address. You're free to try to email me about anything for our software and for today's training session. If you want to request a free trial, just include your name, organization, and module you're interested in the email content. So we'll try to send the lessons and sample data set as soon as possible. And you're also welcome to follow our official channels on LinkedIn, Facebook, and YouTube for tutorial updates and any upcoming workshops announcement. We will announce our next training session very soon, also in the next month, maybe. So once again, thank you for joining us today. We hope this session will be helpful. And these are our partners. You could also get help and free trials from our partner. There are the contact information and the name of our authorized partners. We also noticed that some of them have joined this session. Thank you for all for today's efforts and precipitation again. So if you have any further question, you're free to type in the chat box, or you're welcome to contact direct to us or our partner. Thank you. So this is email address again. I see the chat someone has mentioned